Hi Physical Science, this is Mrs. KJ here, and I'm going to briefly talk over the 3 lab worksheets that you need to do for Unit 2. The first one is 2.04. The molecules of a substance in its gaseous state have more energy than molecules of a substance in its liquid form. When liquid evaporates from your skin, it affects the temperature of your skin. In this lab, you will see how the evaporation of different fluids affect temperatures. For example, that's the reason why you sweat. You sweat so there's liquid on your skin, the liquid evaporates, and that cools off your body temperature. Substances evaporate at different rates. Have you ever noticed that different liquids feel cooler or warmer when they are on your skin? For example, on a hot day, water feels cool on your skin. What about rubbing alcohol or cooking oil? What do they feel like? So go ahead and try them. It's good to try it out, and then that will help you remember and learn stuff better. So hit pause, go try it out. In this lab, you will compare the temperature of a wet thermometer with a dry thermometer to see how the evaporation of different substances is related to temperature. So you're going to watch how the temperature changes when the substance, which is put on this paper towel, evaporates. So you're going to click this link. You might have to hit Control click or copy paste it. And it's a 4-minute video. You may have to hit pause and rewind a few times to get your answers. That's fine. The questions are written in order with this video. Each question is worth 1 point. So answer the questions. Find the difference in temperature. So remember, what does difference mean in math class? It means you subtract. And there's a couple more questions. And turn it in the drop box. And that's all I need for the 2.04 worksheet. Next is the 2.06 worksheet, Phase Change Lab Report. Increasing temperature, melting, and boiling all require energy. In this lesson, you will record how temperature changes as ice melts, turns to water, and then boils. Phase changes require energy. When matter freezes, melts, boils, or condenses, it changes state. That change in state is called phase change, and it requires energy to take place. When ice melts, the temperature of the water eventually goes up, but you don't know how the energy required for the phase change affects the temperature. Does the phase change affect temperature? In this lab, you will see how temperature is monitored during a phase change and use those data to draw conclusions. So in this lab, you observe temperature change as ice melts. So again, here's the link for the video. And go ahead and answer the questions. And now I gave you the data, the time, the temperature, and the state of matter, and you need to put it on the graph paper. However, this is worth 12 points, okay? This is a lot of points. I'm going to check every single point for accuracy, and you need the labels A through D as listed in question 5A. So label the states of matter on the graph. Indicate A, where only ice was present. B, where water and ice were present. C, when only water is present. And D, when water was boiling. This trial started with ice and ended after it was boiling for 25 minutes. So what I mean by that is you are going to have your data points and your lab's going to look something like this. Okay? Then I want you to label on there. So if you want, you can use the shapes like this, or you can color code, whatever is easier for you. But I'm going to say, okay, from here to here, so from this point here to this point here, let's say that that was when the water was boiling. So that's D. So then I would insert a letter D. Again, if you would rather do this by hand, you are more than welcome to, or you can go ahead and do it on Word. If you need help with how to do it on Word, please let me know, and I'd be more than happy to help you with that. Then answer the questions. What temperature does water melt at? Be sure to include a unit with your number. What temperature does water boil at? Describe the slope of the line when a phase change is occurring. Use your graphs in questions 6 and 7 for help on this one. Then use the graph below to answer the next question. Okay, so if we notice, this is a phase change graph. We have an increase in temperature, an increase in energy. So when a molecule is a solid, when a substance is a solid, the molecules are all arranged nice and orderly, okay? And if we notice, the temperature is going up as the heat energy is going up. So it's getting warmer, it's warmer, warmer, and then right here it's freezing and melting. The heat energy is still changing because I'm moving left to right. But am I moving up and down? No. So if I'm not moving up and down, what does that tell me about my temperature? My temperature is constant when it freezes or melts. Why? All that energy is ripping these molecules apart. Instead of being nice and orderly, look at how they are when they're a liquid. So it takes energy to rip them apart. That's the energy that happens during a phase change, which is why the temperature stays the same. All right, so now we have energy is increasing because we're going left to right. The temperature is increasing because we're going up until we hit this point. Now we're boiling or condensing. Does the energy change? Yes, because we're moving left to right. Does the temperature change? No, because we're not moving up or down. So again, during a phase change, the temperature stays the same, but the heat energy changes. Why? Because the molecules are ripping apart from each other. They're spreading out. The opposite is true if we go backwards. If we're cooling down, now energy is being used to put those molecules back together. Cool down, those molecules are getting put back closer together to make a solid. All right, so you got a couple more questions, and then you have a few more questions by using that data table, and that's all you need to do for 2.06. And now lab 2.10. Making ice cream involves the flow of heat. When salt is added to ice, it lowers the melting point of the ice, allowing a mixture of water and ice to become much colder than 0 degrees. So that's why we put salt on our roads in winter. When cream is added to the container whose temperature has been lowered by immersing it in an ice water bath, what will happen to the cream? Can you trace the flow of heat that occurs when a person makes ice cream? Freezing cream involves changes in heat. When you place a bag of liquid cream in water, the cream will not change from a liquid to solid. In fact, normal ice will not cause that change either. However, when salt is added to ice, it will make the ice colder than 0 degrees Celsius. What happened to the bag or cream then? Heat is defined as the movement of thermal energy. How does heat flow in the system? You can try this with cooking materials and additional ingredients to make ice cream. So again, there's a video for you to watch. You might have to hit pause and watch it again, but that's okay. And then go ahead and answer the questions. And that's all you need for this lab. As always, if you have questions, let me know.